Welcome to part 2 of the Day 2 Randomizer Project. Today we're going to start to glimpse a little bit of the power of creating an interface as we create another randomizer. So there won't be a whole lot of new material introduced in this lesson because really at this point what we need is some practice creating classes that we then turn into objects. So let's start by quickly reviewing our randomizer interface. And as we've said, our interface describes any game object that can be used to introduce randomness into a game. And we've already said some common examples include dice, coins, spinners, and decks of cards. Well, it's time to create another new randomizer that will be capable of telling us how many possible outcomes it has, what its current value is, what its current face is, and will be capable of randomizing itself. Our new randomizer is going to be a standard 6-sided die. So we're going to begin by creating a new class, and as an ode to old school Dungeons and Dragons, we're going to call it a D6, which stands for a dice with a die with 6 sides. We'll click Finish. And now let's recall that we want this die to use the randomizer interface. So we begin by, actually before we begin, let's get in the very good habit of adding a Java doc to our class, and let's describe this. This class will model a standard 6-sided die. There's not much else to say about it. That's really all there is, except of course that we want to attach our name, and we're going to use the date as our version number. Okay, so now we're ready to begin. So what are we going to say about this randomizer? Well, first, it implements the randomizer interface. Randomizer interface. And because it implements the randomizer interface, we know that it must implement all of the methods that are part of that interface. So we're going to jump back to the randomizer interface, and we're going to highlight the getters and setters that are outlined in that interface, copy them into our clipboard, and then we're simply going to paste those methods into our D6 class. Now, because they came from an interface, each of these methods ends in a semicolon. Well, what we need to fill in now is the actual code for each of those methods. So we're going to replace the semicolon with pairs of curly braces to give us room to write some code. Okay, we're almost done here. And finally, our mutator method, our final method that we'll need to fill in. All right, so now we're going to sit down and write our method. Before we do, let's fill in some labels as placeholders for common things that are found in classes. And the first thing that we commonly find are instance variables. And remember, instance variables are the persistent memory of the state of an object. The persistent memory of the state of an object. That is what instance variables actually are. Okay, after instance variables, we commonly find our constructor methods. And constructors can be thought of as the factories that turn class blueprints into objects. One way to think about a constructor is, imagine that we're constructing, or that we're creating the class for the Toyota Prius. And so if I were writing the class for the Toyota Prius, my interface would be things like how many doors does the car have would be a getter. And then there would be a setter or a mutator, or an accessor is another name commonly used, that said open door. Of course, there would also be a get number of, or get color. And then, of course, I might have other methods for other features of the car. Well, then the constructor can sort of be thought of as the car factory. If I say I actually want to build a Prius, where do I go? I go to the factory, the constructor, to actually build a Prius. That Prius gets all packaged up and made and driven out of the factory at the end of the constructor. From that point on, how do I interact with my Prius? I interact with my Prius through the getter and setter methods that are part of, built into that object, or in the case of a Prius, that car. Okay, so next I'm going to say, what are my possible outcomes for a six-sided die? Well, that's simple. There's 6 possible outcomes, so I'm just going to return 6. Well, that was easy. All right, then I want to get the current value of my die. And that also should be a number between 1 and 6. But where am I going to store that information? Obviously, I'm going to need persistent memory to store the state of my die. So I'm going to create an integer that's going to be marked as private, because all of the instance variables are information that only my die is privy to. And I'm going to make it an integer. And what am I going to call it? Well, I'm going to say this represents the side that is currently up. Now notice that I am declaring my instance variable, not giving it an initial value. So, little caveat here. I could assign it an initial value, but what is the primary job of a constructor? The primary job of a constructor is to do just that. It's to initialize all of my instance variables and get my object all ready to roll so I can use it for whatever I intend to use it for. Okay, so I've got my side up. How do I return it? Well, that's simple. I just return side up. All right, how about what should show for the face? Well, I'm going to leverage a little ability that Java has to use as a little trick to quickly convert side up into a string. What happens when I combine 2 variables through concatenation that are different types? The answer is, before these two things can be combined, they must be made into the same type. And because an integer is narrower in terms of size than a string, an integer will be expanded into a string value and then combined with the string. And because I'm combining it with an empty string, I'll simply be left with the number represented as a string. Okay. Well, that takes me to my randomize method. How do I get a random number that has a value between 1 and 6? Well, first of all, I'm going to create a random number. So I'm going to create a double that is going to represent my random number. And then I'm going to say that is equal to math.random. And that gives me a number between 0 and less than 1. Remember, this number can never actually be 1. It can be just less than 1. Okay? That's step 1. What's my next step? Well, I need to take that number and multiply it times the range of numbers that I want it to take on, because I want a number between 1 and 6 eventually. So step 1 is to first multiply it by the number 6. So I'm going to multiply it by the range, by the desired range. Now that gives me a number that's actually between, so I now have a number between 0 and less than 6, which is another way of saying 0 to 5.9999999. Bunch of nines. We're just going to put ... to repeat multiple nines. Okay, well, that's nice, except that what I want is a number between 1 and 6. So what am I going to do? I'm going to convert this number into an integer. So I'm going to say int rint equals, and then I'm going to cast that number into an integer. And then I just realized I made a minor mistake here. I used a capital D for double instead of a lowercase d, which gave me an object instead of my primitive class. My bad. Okay, so now I have converted this into an integer. So now I have an int between 0 and 5. Well, that's great, but what I want is a number between 1 and 5. So I'm going to take rint, and I'm going to make it equal to itself plus 1. Okay, and now I'm going to say that side up is equal to that integer value. Now, if this seems like a really complex way to calculate a number, to come up with a random number between 1 and 6, now I have an int between 1 and 6. Of course, I can simplify many of these steps. So let's go back and do that. First, I don't actually need rint here. I can say side up is equal to rint plus 1, saving myself one line of code. Then I can say, well, you know what? I actually don't need rint. I'm using rint one time right here. So I'm just going to take this little bit of code here, and I'm going to substitute it where I have rint. Okay, well, I'm one step closer. Then I have to ask myself, well, do I need to multiply this number as a separate step, or can I simply take this and multiply my random number by 6 in one step? And of course, the answer to that question is yes. Yes, I can. Well, now I have to ask myself, if I only used r exactly once here, I declared it and calculated a value, but then I only used that value one time, do I really need that variable at all? And the answer again is no. I can just take the value assigned to that variable and substitute it in the place of r. And now I'm left with a much more compact number. Okay, so now I've randomized my side up. Well, what's the one method I haven't created yet? I haven't created a constructor for my D6. And let's recall the structure of a constructor. First, it must have the public keyword, because what would be the point of having an object that I can't actually make, and I can't make it if I can't access the constructor. And then the rules for the name of the method are that it's the same as the class, and I'm making what's called a default constructor, which means there won't be any parameters. So I'm going to label this as my default constructor. And what does my default constructor need to do? Well, that's quite simple. It just needs to assign a random value, which I can do by calling the randomize method. Now, it's important to recall that when I say randomize here, there must be a randomize method within this class for me to call. Is there a randomize method that I can call within this class? Yes, there is. It's right down here, and therefore I'm allowed to just say randomize, because it's unambiguous as to which method I'll be calling. Okay, so now I've got my 6-sided die. What am I going to do with it? Well, at this point, I'm going to want to create a simple program to let me test my die runner, or my die. So I'm going to create a new class called Dice Runner. It's going to have a public static void main. And the Dice Runner class is simply going to instantiate a 6-sided die and roll it 10 times. That is my goal. So I'm going to put the date on, and then I am ready to roll. Get it? Roll? All right. So now, how do I instantiate a die? How do I instantiate a die, a 6-sided die? So remember, instantiating an object is essentially the same process as declaring any other variable, just with a small twist. Whenever we're declaring a variable, we start by including the type of the variable. Well, the type is the class. So it's D6. Then I need a name for it. I'm just going to call it die. And then I'm going to say, I'm going to use equals to assign a value to it, and I'm going to use the new keyword, which is going to trigger a constructor, and my constructor is the same name as my class. Then I'm going to output the value of my die. Okay, well, now we've got a very short test program, so let's just run it and see what we get. Notice that we got the default toString result because we did print line die. Well, that's not what I want. I want something much prettier. So I'm going to go back to my die class, and I'm going to add an overridden inherited toString method from the object class. And that's quite simple. I simply say public string toString, and then decide what I actually want to return. Well, in traditional Dungeons & Dragons, when we're printing a die value, we actually print it as lowercase d followed by the number of sides on the die, and then we state what its value is. And I'm going to do that using getCurrentFace. And please recall that this is the better way to do things. I could have just put side up here, which would have given me the same result right now, but at a later date, doing it this way gives me added flexibility, and we'll see how that happens very shortly. Okay, so now it's time to go back to my dice runner and see what I get. D6 equals 2. Excellent. But now I actually want to write something a little bit different, so I'm going to say initial value equals, and because I'm doing that, I'm going to do getCurrentFace. And because my toString is different than my getCurrentFace method, I'm just getting the number back, which is great. That's what I wanted. Now I'm going to roll the die 10 times. Okay, so I'm going to do that with a for loop. Okay, and now I'm going to say within the loop, each time I'm going to randomize the die, and then I'm going to print out roll number, and then I want to print the value of how many times I've rolled the die, and then I'm going to put a comma, and then I'm going to output the value of the die. Alright, and now I am ready to roll. This time I'm going to show my console output, and here I got initial value 2, roll 1, d6 equals 3, roll 2, d6 equals 6, etc., etc. And as you can see, I've got my complete output, and here is my completed dice roller.